All right, this says solve the equation using the quadratic formula. Okay, if necessary, leave your solutions in radical form. Okay, well, to use the quadratic formula, the first thing we need is we need a quadratic equation. So we're going to have to add that 10x to both sides. And then I get 2x squared plus 10x plus 8 equals 0. And then you don't have to do this, but let's make it as simple as possible. Let's divide everything we can by 2. And that way we just have smaller numbers to deal with, which can make our lives a little easier. So I'm going to divide everything by 2, and I get equals 0. So then A is equal to 1, B is equal to 5, and that was a 5. It's just an interesting 5. And C is equal to 4. Okay. Remember, if you make it thick enough, kids, it's all good. All right. So now we can use the quadratic formula. So x is equal to negative b, which is negative 5, plus or minus the square root of b squared, which is going to be 25, minus 4 times a times c. Okay, all over 2a, which is 2. So then try to keep this straight. This is negative 5 plus or minus 25 minus, well, 4 times 1 times 4, that's 16. 25 minus 16 is 9. So the square root of 9 over 2. Looks like that's going to give really nice solutions. So in fact, I'm not going to need any more space because I'm ready to go. So let me erase this, and my computer's really confused. It's just thinking for a long time. Okay, so now I have two equations. X equals negative 5 plus 3 over 2, and x equals negative 5 minus 3 over 2. Negative 5 plus 3 is negative 2. Negative 2 divided by 2 is negative 1. So x equals negative 1. And negative 5 minus 3 is negative 8. And negative 8 divided by 2 is negative 4. And so the solutions are negative 4 and negative 1. If you substitute those back into the original equation, they should make the equation true. And that could have probably much more easily have been done just by simply factoring. Not probably, it would have been easier done just by factoring. But it asked us to use the quadratic formula, so we used it. Okay, simplify. Okay, I always say to try to simplify the inside of the radicand first. We actually did this as a group and found that it didn't make it easier. It made it a little harder. But I'm just going to pretend that you're following my instructions to simplify everything inside before you move on. So 18 and 144. 18 is a factor of 144. How do I know that? 18 is a factor of 36. 36 is a factor of 72. So 18 goes into 72 4 times. So it'll go 8 times into 144. And so you're going to get y to the 5th over 8x to the 8th. Okay, now we're taking the square root. So what we want to do is we want to write each factor, and you can use the product or the quotient property of square roots now. Y to the 5th is y to the 4th times y to the 1st. Why did I just do that? Yes, that's true, right? Product of powers property. You keep the base, add the exponents. Why did I just do this? Because these are rational exponents in disguise. Y to the 5th, when you're taking the square root of that, that's the same as y to the 5th over 2. Okay? Now, if I write y to the 5th as y to the 4th and y to the 1st, y to the 4th, having the square root, is y to the 4th over 2. So what's 4 divided by 2? 2. So y to the 4th, when you take the square root of it, you get y squared. Okay, that's cool because then that's a perfect square. Same thing goes for the denominator. We're taking the square root of 8, but 8 has a perfect square factor in 4. Square root of 4 is 2, and then you get the square root of 2. And then that's times x to the 8th. Well, x to the 8th, that's 8 over 2. So x to the 8th is a perfect square, so we'll just leave that as x to the 8th. Now let's keep on going. Y to the 4th, when you take the square root of that, you get y squared times the square root of y, all over square root of 4 is 2. Square root of x to the 8th, that's 8 over the 2 for the square root, that's x to the 4th times the square root of 2. Uh-oh, we have a square root in the denominator. We're going to have to rationalize the denominator so we don't have an irrational number in the denominator. So you get y squared times the square root of y over 2x to the 4th times the square root of 2. We multiply by the square root of 2 over the square root of 2. Why is that? When you multiply square root times square root of a times the square root of b is equal to the square root of a times b. And so square root of 2 times square root of 2 is the square root of 4, and that's just 2. So now we have 2x to the 4th times the square root of 4. And the numerator, we have y squared times the square root of y times the square root of 2 is the square root of 2y. So that's y squared times the square root of 2y. And if you keep on going on this, the square root of 4 is 2. 2 times 2 is 4, so you get 4x to the 4th. And in the numerator, you get, well, that stays exactly the same. So it's y squared times the square root of 2y. And you are done. Yay. Oh, it's so fun. All right, done with that one. Moving on to the next one. Oh, square root of 10 is in the denominator. We're going to have to multiply by the square root of 10 over the square root of 10. I should have said first, 10 does not have any perfect square factors, so there's no way to break that down any further. And so then we just get square root of 10 times square root of 10 is the square root of 100, which is equal to 10. And then you get 4 times the square root of 10, and you think that you're done, and you're like, yay, I'm finished, but 4 over 10 actually reduces. 2 goes into both 4 and 10. That becomes 2 square root of 10 over 5. All right, guys, that'll do it. I know I was going fast. That's because I'm trying to finish before I have a meeting right now. So I wish you the best on the test tomorrow. Please email me if you have any questions. You're all amazing. My computer is now in the middle of crashing, which of course it is. It always is. Have a good day. Bye.